Designing for Noticeability – Understanding the Impact of Visual Importance on Desktop Notifications. I am Philipp Müller from the DFKI in Germany, and this is joint work with my colleagues Staal, Mihai Bâce, and Andreas from the University of Stuttgart. Desktop notifications convey important information, but they can go unnoticed when the wrong design choices are taken. For example, the noticeability of desktop notifications is highly dependent on their placement. However, how exactly the background impacts the noticeability of desktop notifications is not well understood. This is mainly due to the fact that no dataset of high quality and high variability desktop images is available. Furthermore, it is unclear what properties of the background to quantify to investigate effects on noticeability. In this work, we create the first tool to synthesize realistic desktop images. With a user study, we show that visual importance of the background at the notification location significantly influences noticeability. Visual importance encodes the importance humans assign to the different graphic elements of an interface. Finally, we propose noticeability maps that encode the likelihood of detecting a notification at each desktop location by combining visual importance with other notification design choices. With our synthesis tool, we created desktop images and notifications from the three major operating systems macOS, Linux, and Windows. Please note the high level of detail and variability, including realistic taskbars and different configurations of opened websites and applications. Notifications can be generated with different aspect ratios and with as well as without buttons and icons. All parameters of the generation can be easily controlled, and we made our tool freely available for research. With these desktop images and notifications, we performed a 33-participant online user study. Participants had two tasks. First, they had to follow a randomly moving dot across the screen with the mouse pointer. If the mouse pointer was inside the dot, it was shown in green. Otherwise, the error was indicated by the dot turning red. In this way, we fixed participants' visual attention to a specific location on the screen. The second task was to press the spacebar whenever a notification showed up. Notifications were also shown at random locations on the screen, and we additionally sampled notifications of different size, opacity, and aspect ratio to investigate how these factors interact with the visual importance of the background. To extract visual importance on desktop images, we used the Unified Model of Saliency and Importance, UMSI. UMSI is a CNN-based encoder-decoder model that is applicable to both graphic designs as well as natural images. This is important for our application, as desktop images can contain both graphic design elements as well as natural images. In order to better capture which regions in the image stand out relative to the expected visual importance distribution on desktop images, we subtracted the average visual importance computed over all desktop images generated for a given operating system from each single visual importance map for the corresponding operating system. Image C shows the average visual importance map for Linux. It shows a bias to the upper middle of the image, where title bars of open windows are often located. To quantify the visual importance of the desktop image at the notification location, we averaged the values of the final visual importance map that are covered by the notification. On the right, we show the detection probability of notifications for bins of notifications with different visual importance values. Most importantly, our results show a clear connection between visual importance at the notification location and the probability of detecting the notification. The relationship is inverse, meaning the higher visual importance leads to a lower noticeability. A low-level explanation of this effect could be that the visual importance measure we used is correlated with visual clutter. This is plausible, as high visual importance is usually assigned to regions in the image containing a large degree of clutter. A large degree of visual clutter, in turn, could make it more challenging for notifications to stand out from their surrounding. A possible higher-level explanation could be that users do not expect notifications to appear at locations that already contain UI elements like application windows or opened websites. Such UI elements often get assigned a high visual importance, leading to the inverse connection between visual importance and noticeability. In addition to effects of visual importance, We also saw clear effects for the distance of the notification to the user's current focus of attention, as well as the notification size and the notification's opacity. The closer a notification is to the user's focus of attention, the easier it is to detect the notification. Furthermore, larger notifications get noticed with a higher probability, and the same holds true for notifications with high opacity. The relationship between aspect ratio and noticeability is more complex. There's an advantage for notifications with aspect ratios close to 2. This is close to the aspect ratios used by the most common desktop notifications people experience in their daily lives, and might indicate a bias that results from such experience. We also checked whether notifications placed at canonical locations, for example the upper right on macOS, have an advantage but did not find such an effect. Here we visualize the interaction of visual importance with the other notification design factors distance to the attention focus, notification size, and opacity. Let us focus on the leftmost plot showing the connection between visual importance and detection probabilities separately for small, medium-sized, and large notifications. There is a clear interaction. For low visual importance values, the difference between the different size categories is much smaller as compared to large visual importance values. Small notifications will still be noticed with high probability when placed at low visual importance locations. We observed comparable interactions of visual importance with notification opacity, as well as with the distance of the notification to the user's focus of attention. This is a valuable insight for designers, as it can allow to choose a low opacity notification designed for aesthetic reasons, but still ensure high noticeability by minimizing visual importance of the background. To visualize the expected noticeability for each location on the desktop, we propose noticeability maps. These can be helpful for designers when trading off different notification design factors with respect to noticeability. In this example, we show noticeability maps for notifications with medium size and opacity. Regions with high expected noticeability are shown in blue, and regions where a notification might go unnoticed are shown in red. Note how the visualization changes in response to the different attention focus of the user. To conclude, we presented the first study on noticeability of notifications placed on realistic desktop images. We showed that visual importance of the background significantly impacts noticeability, and furthermore we introduced noticeability maps that can be helpful for designers. The tool we built to create realistically looking desktop backgrounds is free to use for research. Thank you very much for your attention.